All right, there it is. So take a look at it. They're asking us in part A, where is f of x less than 0? Does everybody see that? Right here. Where is f of x less than 0? So now, what is f of x? F of x is y. Remember, function values are y values? So they're basically, happy Valentine's Day to you. Even though you're not my sweetheart. But happy Valentine's Day to you anyway. Are you guys ready for math? You're just looking a little tired this morning. We all good? You ready and alert? All right. So, y is less than 0. So function values are y values. So they're asking us in part A, where are the y values less than 0? Look at the picture. Where are the y values less than 0? Well, be right there and there. And onward, to places it's under the x-axis, right? Does that make sense? Those are the places. So where's that? That's from, and where do they say where? They mean what x values? From 0 to 1 and from 3 onward. In those sections of the x-axis, the graph dips below, doesn't it? The y values are less than 0. The y values are negative. Right? So the answer would be, okay, where is it? They say give interval notation. So that would be between 0 and 1 and from 3 to infinity. Is that good? Does that make sense there? And then part B asks where, down here, part B will say where is the function values, meaning the y values, greater than or equal to 0. And that would be the other places, That would be right there and right there. So that would be from negative infinity up to 0, and from 1 to 3, From negative infinity to 0, and 1 to 3. Is that making sense? Yeah. I'm wondering that same thing, and I do not know. Yeah, they want brackets, or, on a test, I don't care. I think that's all dumb. But, well, no, it's not dumb. No. I take that back. No, we do need to be a little, I'm being too casual. It's my fault. Yeah, let's look a little more closely. So, yeah, if they say on part B, let's finish with part B, then we'll back up to part A. Part B, less than or equal. Well, maybe I should erase all my scribbles here. Right at 0, it's equal. It's right on the money, isn't it? So we should include that. Are you with me? It's saying, where are the y values above 0 or right on 0? Well, at x equals 0, the y value is right on the money 0. So we want to include that with a solid bracket at x equals 0, right? How about from 1 to 3? Same thing, both solid brackets. Because right at 1 and right at 3, the y value is right at a height of 0, isn't it? And they want us to say everywhere it's greater than or right on 0. As opposed to if I back up now to part A, we want open parentheses on all those, always by infinities, right? You're never right on infinity. And even the numbers, right? Because they're saying, where's the function, back in part A, where's the function below 0? They don't want it right on 0. They just want, where's the height below 0? Well, between 0 and 1, but not right at 0 or right at 1. Right at 0 and right at 1, it's at exactly a height of 0. So we want between 0 and 1. Not including the endpoints. And same thing. At 3, right on 3, it's at a height of 0. So if we're saying where's it below 0, then that would be just to the right of 3, parenthesis. Not a bracket. Yeah, so no, it does matter. You're right. Good question, good point. There's the right answer. Does that make sense then? So basically, wherever they have the equals bar, we're going to have the brackets, other than on the infinity. That's more simply stated, Right? So part A was just less than. It wasn't less than or equal to. So we had parentheses on everything. Part B had greater than or equal to. They had the bar, so we have the brackets. BB goes together. When they got the bar, we got the brackets, other than the infinity, because we're including right on the spot. Good. All right. Okay. So part A, let's do part A first off. Where is the function below 0? So part A, where is f of x, or again, that means y values, Where are the y values? Where's it below? So let me let you go ahead and write the answer on your own papers there. Where is that thing below? Where's the graph below? It looks like, right there and right there, huh? Those are the two parts where it's below. So, and we don't want, there's no bar here. It's not less than or equal to, it's just less than. So we're going to have parentheses on all of our interval answers, huh? We're not going to include any endpoints. So where's that? That's from x is -2 up to 0, and from 3 to infinity. We good? So from -2 to 0, and 3 to infinity. Make sense? They always want x value, right? This is an x value, x value, x value, x value, right? They want sections, interval. Interval means x values, doesn't it? Right? Whenever they say give me an interval, they mean x with x. X with x, they mean along the x-axis, don't they? So those are the sections of the x-axis from -2 to 0 and from 3 to infinity, right? Where the thing is below. It looks like, I don't know, I kind of wrote over the top of it. See that arrow? Oh, okay. Yeah, I kind of scribbled over the top of it. But yeah, so it just keeps going. Yeah, it looks like it's got a horizontal asymptote there. It's going to level off and keep going to the right forever. All right, good. Now, and then part B, erase the part A work. Go ahead and do part B real quick. Part B is asking, where is it f of x greater than or equal to, meaning y greater than or equal to 0. Go ahead and try that one. Now we're including the equals bar, right? So we might end up having brackets on a lot of things. So where is it greater than or equal to 0? Well, it looks like this section, this section. Those two sections are above, huh? So where's that? That's from -infinity up to -2. And from 0 to 3. -infinity. Now, at the -2, let me ask you. At the -2, does it actually hit the -2 straight on the money? No, you never hit a vertical asymptote. You never touch those. They're not in the domain, right? So actually, we end up with a parenthesis on that -2. Normally, we would put brackets by the place where we have the equal to, right? But never at a vertical. So the vertical asymptote is an exception to that, as is infinities. You can never touch infinity. You can never touch a vertical asymptote. Otherwise, we're going to put brackets on everything with the equals case, right? So how about from 0 to 3? That little piece, that piece right here, from 0 to 3. Bracket on the 0, parenthesis on the 3, because again, the 3 is a vertical. But the 0 will get a bracket, won't it? Because we are doing the equals 0 case. And at 0, it's straight on 0. So we bracket that. So basically, the rule is, putting it more succinctly, whenever you have greater than, or when you have the equals bar, it's going to be brackets on everything except infinity and vertical asymptotes, right? That's the rule. So if you have the greater than or equal to, or less than or equal to, or whatever, it's going to try to do brackets on everything, but you can never do it on a vertical. And never on a vertical asymptote, never on an infinity. All right. Time for that, but I'll do one more quick. All right, so how about we just do that? All right, you got 5 seconds. All right, no, I'll give you maybe 10. So they're just going to ask the one question. They're not going to ask both this time. See, this is all parts showing. So they're only going to ask that. So just answer that, nothing more. Just answer that. Where is the function? Where are the y values? Less than or equal to 0. That's what they're saying. F of x less than or equal to 0 means y less than or equal to 0. That'd be here. That'd be here. Huh. And you want to put brackets, because it has the equals bar, if, other than infinities and vertical asymptotes. Put brackets on the things. Right? So what intervals on the x-axis does that mean? From -infinity up to, what is that, -2? So that one, bracket at the -2, because that's not a vertical. And from 3 to infinity, bracket on the 3, right? Let's put a comma, there's our answer. Is that good? It's just like the others. Now, what they're about to shift to, they're warming us up. They're about to say, hey, look at that. That's the equation that has that graph, right? They got an equation. They gave us the picture. Next problem, or a couple problems down the line, I don't exactly remember, they're going to have us fly blind. They're not going to give us the picture. All they're going to give us is the equation. And they're going to say, you figure it out just from the equation without having the picture to look at. That's where we're going. How could we do that? How could we figure all this out without a picture? The 2 and the 3, right. Yeah, let me get a fresh screen here and look at that. How could somebody give me this equation without the picture, that's where we're going for the last 20 problems, basically, and figure all this out? Somebody could give me that function. So, all right, here's your function. We'll run out of room if I put it over there. Here's your function. It's minus 2, x minus 3, x plus 2 cubed. Tell me where that thing is less than or equal to 0 with no picture. How would I figure that out? How do you find? Well, let me just give you the basic steps. You would need to, first off, if you had no picture at all, you would need to figure out where the thing hits 0, right? Meaning this, whoop, that was a big spot there. Meaning negative 2 and 3, we already know because we've got the picture. But if I didn't already know that, how would I look at this and know it's at negative 2 and 3? That's what you guys were already saying, huh? Right? You would just say, well, take that thing. So here's the steps. I'm going to walk you through the steps while you have a picture to look at, and then we're going to take away the picture for the other problems. So step 1, we can clearly see, is set it equal to 0, right? Even though it originally is greater than or less than or whatever it is, you need to first find where it equals 0. Because where it equals 0 is the dots on the x-axis, huh? Those are crucial spots. That's where it changes from being below to being above. Do you see that? Everybody said, make sure you know, it's always best in math and science to get the logic. I mean, I'm going to write out steps, and you can monkey see, monkey do the steps. But you'll do way better if you get it. Because you'll forget all the steps, because you have your 3x5 card. But you can also kind of mess them up. You know, if you don't really get it, you're just kind of blindly, right? Try to get what I'm saying, right? So does it make sense? You've got to find these spots where it hits 0. If you really want to find where it's below and where it's above, well, then these are crucial places where it switches from being below to above, right? Okay. So then you solve this, and you know how to solve this. Everything that has an x can be 0. It has a chance to make the thing 0. Not the negative 2. Forget about that negative 2. If it was negative 2x, I would set it equal to 0. But it's just negative 2. Skip him. Just do the x minus 3. Just do the x plus 2. I don't care cubed. I don't care about that. I just want the thing to be 0. 0 to the third power is still just 0. Right? That doesn't mean anything to me. So x is positive 3, x is negative 2, as we already knew. Those are the two values that you can plug in for x that'll make that whole thing equal 0. Plug in either one of those values. And one piece will be 0, and since they're all multiplied, the whole thing will be 0. Right? Okay, so what? So that's your first step, is find those. Next, so you say, okay, so I found, whoops, come on, there you go. So we found x is positive 3 and x is negative 2. Let's say, we're pretending we have no picture. Then you would go to the number line, you would go, okay, negative 2 and positive 3. Those are the places it hits 0 and nowhere else. So now I just need to figure out, is it like below here and then maybe above and then below? Or maybe it's above and then below and above. I don't know. You know, I got to figure out which of those it is if I want to know where's it above and where's it below. Where's it positive and where's it negative, right? So how would you figure that out if you didn't have the whole picture? I mean, I want to not do the entire graph, but just do just enough to get the information I need out of it. So how would I do that? Well, you could just plug in values, for example, right? You could just say, hey, I'm just going to plug in some value. Let me give you a couple ways to go. I'm going to plug in some value in this section, say like negative 3. And some value in the middle, say like 0. And some value in the right, say like 4. And just plug it into the original function and find out if it comes out positive or negative. Because whatever it comes out, it's that for the whole section. It can't switch again because it doesn't hit the x-axis in the other places, right? You with me? So if I plug into the y equals, what is it? In fact, let me go up here because I don't have room down there. I should have put it higher up, but anyway, it's fine. So come up here, and I'm going to plug into y equals, what is it, minus 2 x minus 3 x plus 2 cubed. I'm going to plug in negative 3. So I'm going to put in negative 3. I'm putting in negative 3 because I'm testing this section. I'm saying, hey, is it up here or is it down there? Is it above or is it below? Is it positive or is it negative, right? So plug in. Find out what y is at negative 3. Whatever it is at negative 3, it's there, that whole section. So let's see, negative 2, which would be negative 6, negative 1 cubed. So then just work it out. Use your calculator. Negative 2, negative 6, and this is negative 1 when you cube it. 3 negatives, so it's negative 12. So it's down here. It's negative, isn't it? So that means the graph is down here and then hits. I don't care exactly where. In fact, I don't even care negative 12. It's just negative. That's all I really care about. It's negative at negative 3. When you plug in negative 3, the height of the function is below. And, of course, we know that by looking at the graph. And it's got to be down here. And that's actually not what it looks like because we have the real graph. But I don't care. Good enough. I just care that it's down. Right? Now, how do I know it couldn't come back up? How do I know it's down everywhere left of negative 2?
It's a negative polynomial.
What?
It's a negative polynomial.
Negative polynomials can do that.
There's no other zero.
There's no other x-intercepts. There's no other x-intercepts.
Oh, okay.
Right? If it came back up, there'd have to be another x-intercept over here. Another equals 0 place. We already found that only negative 2 and positive 3 hit the x-axis. They're it. Robert?
What I was saying was because it's a to the fourth power,
Right.
the whole polynomial, it has to be in the shape of somewhat like a parabola, so you know that it's not going to come back up on that side.
We got to be a little careful. I mean, you might be right. I don't want to get into all of that there, but you got to be a little careful with that. Yeah, there's other more complex ways. But simply put, right? There's no other x-intercepts.
Right.
It can't come up again. All right, let's check the middle. Let's check the middle between negative 2. Now, I picked 0. You could have picked negative 1, positive 2, whatever. Just pick any one point in that section, and whatever it comes out to be is true for the whole section because, again, there's no other x-intercepts. So plug in to, again, y equals minus 2, x minus 3, x plus 2 cubed. What am I plugging in? 0. Put in 0, put in 0. What do you get? Minus 2 times minus 3 times 2 cubed. Is that negative or positive? Because that's all I care about. Negative times positive. What is it? Positive. It's up here. And it's got to be that way for the whole section because there's no other x-intercept spots, right? We good? And now what is it over here on the right? Plug in 4, again, into the same function. Around the screen, yeah. So plug in 4, and we get minus 2 times 1 times 6 cubed. Is that positive or negative? Right? Negative times positive, negative. It's down here for the whole section. Okay, now what is it? Now that's not exactly what the graph looks like. We have the real graph staring at us. But that's all I need to know to figure out where, what was the original question? Where is f of x? I don't even know now. Oh, there it is. It's right here. Less than or equal to 0. Where is y less than or equal to 0? We're here and here, right? So that's how we got our answer. Does that make sense how you could do this by hand without doing the entire graph? That's what we'll do. We'll just find the 0 spots and then check between them to find out if it's above or below, because it can't change its mind any other places, can it? Does that make sense how this is going to work on that? And, oh, there's one other way we can know. Here's another easy way. What you could do, let me go back and do this one more time. Well, maybe I should stay on that same screen. Remember what we learned about these points and whether they're bouncers or pass-throughs? Remember us talking about that? That would be another quick, easy way to go. Let's come back over here. Whoops. Yeah, well, no, let me do that. Let me do this one other idea. You could do either way you want. Doesn't matter at all. So suppose you're doing your work and you go, okay, I found, negative, what is it, negative 2 and positive 3, And then you could just check one interval. Say you were over here and you found out it was below or whatever. Or you could do in behavior. Yeah, how about that? Remember we learned about in behavior? What it does come on. Way over there? What's in behavior on this one? This is kind of like what Robert was talking about. What's the in behavior? It's negative, right? If you plug in 1,000,000 into that thing, it's going to be -2 times a million, you know, whatever. It's going down, right? If you plug in some really big number like 1,000 for x, those are just huge, times -2 is negative. So my point is it's going like this. It's end behavior. Remember how we learned about end behavior? Let me do a better job on that. I'm kind of sketchy. End behavior. End behavior is y equals -2 x to the what? 4th, right? Remember how we learned you just take it's just the leading coefficient, right? If you FOILed all that out, you would have -2 times x to the 3rd. -2x to the 4th, in other words, right? You with me? Remember the end behavior? How we learned to do that? So if you FOIL that whole thing out, the leading term would be -2x to the 4th, and then smaller stuff. So that means he dominates, and in the end it's going down. And then we could just say, hey, is this a bouncer or a pass-through? Is this a bouncer or a pass-through? Remember how we learned whether a point is a bouncer or a pass-through? What makes a bouncer bounce? Even powers. Remember, even powers, like that's why x squared bounces, and odd powers like x cubed pass through. Remember that? So we learned that, so we can just say, okay, well, let me look at these particular ones. Is this guy at +3? Where's he? He's, which term is he? +3. Oh, he's this term. That's to the first power. That's odd. So he's going to pass through. And what about -2? There he is. That's the -20, third power, odd. So he's also going to pass through. So that's quick. You don't even have to check any intervals. You might like that better. Just do the end behavior and then the pass-through bouncer. And you know, all right, so here's the negative section, here's the negative section. There's my answer. All right, is that good? So those are some options for you. We'll really be ready to fly by the instruments with no window to look out. So let's do one more. So we can, because we have the picture, it's cake, but let's pretend we didn't have the picture. And all we had was this. What are the crucial locations? First off, all you had was this, and you're like, I have nothing to look at. I just got this thing. I got to figure out where it's. What do they want? They want, where is the function greater? Where is y greater? So I got to find out where it's above, right? Where is it above? I have no picture, let's suppose. What could you do with this? Now, it's a little different with a fraction. That's why I wanted to show you. The last one was not a fraction. This one is a fraction. Those are the two cases that are a little bit different. Why? Because fractions have verticals. So on the last problem, where there was no fraction, all I needed to find the turning points, where it went from below to above or above to below, was where it was 0. But now, which is like right here, that's the only place, that's the only x-intercept, right? Right there. So that's what I would find if I set it equal to 0. But that's not the only place on this picture where it goes from above to below. Because it's a fraction, it also changes its mind at the verticals. See, left of the 3, it's below. Right of the 3, it's above. So it's not only intercept points, but it's also verticals that you have to examine for the function changing its mind. And those are the only two places it can do it. Verticals and intercepts. So how do you find verticals and intercepts? Well, you guys know all about that. We just did that in the last section, right? So first off, when you have a fraction, if you have a fraction and you have no picture, number one, numerator equal to 0. So just x minus 2 equal to 0, solve it, x is 2. See what we found? We found that 0. Just the numerator. Why? You're going to go into calculus, are you? Is that your plan? Probably a lot of you. You're going to go into calculus. I still remember teaching calculus several times, and us dealing with a function. I remember putting a function on a test like that, and I said, find the intercepts, find out where that thing is 0. And a lot of my calculus students being confused. For whatever reason, I just hadn't specifically covered that exact example in lecture. But I was like assuming that they knew by that point in their math career how a fraction equals 0. I remember all this confusion, like, we didn't know that, Mr. Heron. I was like, you should know that. How does a fraction equal 0? If I say, hey, I got something over something, and it's, this is some number over some number, and that fraction's coming out to equal 0. You tell me, how can a fraction equal 0? Does the bottom have anything to do with it? No. It's only the top. The only way a fraction can equal 0 is if the top is 0, right? So that needs to be solid in your mind for the future of math. That'll come up a lot. So, right, the only way you can make a fraction, if the bottom's 0, that's undefined. That's not 0, right? So that's different, right? So if you want a fraction to equal 0, the top needs to be 0. That's the only way. It has nothing to do with the denominator, does it? I remember my calculus students on that test fiddling around with the denominator. I remember reading their stuff going, what? And wasting, not hours, but precious minutes of their time factoring the denominator and fooling around. I remember thinking they're just killing themselves because they don't know the basic fact that the only way a fraction can be 0 is if the top is 0, right? All right, so with that in mind, when I get onto this problem here, and I say I'm saying where's the numerator 0, I'm really saying where is the whole function 0? Why is 0 at x is 2? The whole function is 0 when the top is 0, and that's the only place. Sure enough, look at the picture. That's exactly what the picture tells us. All right, now, we do care about the denominator by itself being 0 also. Why? Why do we care so much about that?
That's the vertical asymptotes.
Those are the verticals, which are also crucial places where it can pivot from below to above or above to below. So then you set the denominator all by its lonesome, all by itself, equal to 0, and solve that one. So what does that mean? X is 0 or x is 3. And sure enough, at 0 and at 3, this one's 2, we see verticals, and those are crucial places. So then you would say you would get those locations. So for a fraction, notice we set the top equal to 0 and the bottom equal to 0. And we find the 3 crucial and only places where the graph could change its mind from being below to above, from below to above. To only places. Nowhere else can it change its mind. And so that means those are the places where we check the positive negative thing, right? We would check those intervals, right? Am I making any sense? Let me do one more screen. I don't want to use up too much time, but so in other words, I would go once having found 0, 2 and 3, I would go, okay, 0, 2, and I would just, I know 2's closer to 3, but whatever. I'm just going to space them out even so I can have some room to work. So really this breaks the whole number line into 4 sections, doesn't it? 1, 2, 3, 4 sections, right? 3 breaks into 4 sections, right? All right, so then I need to check each of those sections and find out which ones are positive and which ones are negative. You can plug numbers into all of them, or you can try to do the, but we can only do the bouncing. I'm trying to think with you. I'm thinking this out with you. The bouncing pass-through thing at the 2, huh? Because he's the only one that's that's a 0, right? Whereas 0 and 3 are verticals, aren't they? So we can't really. I'm trying to think. There's no easy way. There's no easy way to test them. You just have to plug in values.
Well, if you know that they're vertical asymptotes and you still did it as if it was one continuous graph, couldn't you still see that greater than 3, it's above the graph?
We can still do the end behavior, if that's what you mean.
I mean, it wouldn't be exactly like the picture that you could. I think you could still get the same idea of what's above and below as long as you remember which ones are asymptotes.
Let's try the end behavior. So that would be x over x squared. Remember, end behavior is highest power, right? Everybody see what I'm doing? Remember, end behavior, highest power on the top is x. Highest power on the bottom, if you foiled out the bottom, would be x squared, right? Which is 1 over x. So my point is that positive or negative way off to the right? Positive. So that means way off to the right is positive, which we see is true on the graph. It is positive. It's not really like I drew it. But it's above the x-axis. That's all I care, above or below, right? It is above. That's true. But coming into this asymptote, how do I know on the other side if it's going to be down here or it's going to be up there? What will tell me that without plugging in? I can't think of anything.
The degree? Or is it?
No. I mean, you can do complex things. I can't think of anything easier than plugging in, I mean. Yeah, we could sit around and conjecture big fancy things, which is basically you're graphing the thing at that point. I'm looking for something easy. What's that?
What about the pattern of the graph? If you notice that in the top part of the quadrants, quadrant 1 and 2, if they both run the same way, they both run the same direction, And then the same thing.
Why do they have to, though? Like, why couldn't we? There's lots of graphs that do this kind of thing. So why couldn't it do that? Yeah, I could be missing it, but I don't see anything easier than just plug it in.
I don't either, it's just a question.
Yeah. So I'm just trying to find the easiest way for y'all. I think at this point you're going to have to just plug in for that section. I don't see anything easier to decide than just, I mean, there are other things, but they're basically graphing, so we might as well just plug in. So what I'm saying is to find between 2 and 3, this section, whether it's above or below, plug in a value. Now, what can I plug in between 2 and 3? 2.5. Yeah, just use your calculator. Plug in a decimal, 2.5. You can't remember, you don't want to plug in the edges because it doesn't exist at 3, and at 2 we already know it's at 0. That won't get us anywhere. You want to plug between them always, right? So just plug in 2.5 to the thing. Now remember, you don't have to do a lot of work. All you care about is it positive or is it negative? I don't really care exactly where it is. So plug in 2.5 to what? To the original function. So y equals x minus 2 over x times x minus 3. So plug in 2.5, 2.5. So what am I going to get? Can I do this, guys? Positive on the top, positive times negative. Is that okay? Do you see what I just did there? I plugged in 2.5, right? 2.5 minus 2. Well, it's positive. Right? I don't care what the number is, right? Into x right here, 2.5. Well, it's just 2.5. It's positive. Plugged into this one, 2.5 minus 3. That's negative. Everybody see that? Quick and easy, right? What's positive over positive times negative? Well, that's positive over negative, which is negative. So I know it's negative. Yeah.
Is the fact the end behavior is y equals 1 over x a big thing to do with the shape?
Not after the asymptote. All it means is it's above here. Yeah, there's nothing that I know of that's reliable, that's easy to know for sure. So it's down. So that means that what I know is the graph is down here. Somehow it's down here between 2 and 3. Make sense? Because it came out negative. Now, I could do the test at 2 to find out whether 2 is a bouncer or a pass-through, because that is a 0. So look at 2. Look back at the equation. X minus 2. What's the power on that piece? First power, odd. So what does that mean? He's a pass-through. He's going to pass through. So that tells me that. So I get that kind of good information. But now, over in this section, I'm going to have to plug in again, because I have no idea. It could be up here. It could be down there. I've seen graphs do all kinds of things. So the only way we're going to know is by actually plugging in. So you would plug in a value that's in this section. What's a value in this section, like over here? Be like -1 or something. Something left of 0. Plug in negative. Where do I plug it into? The original function again. So let's do that one more time. X minus 2 over x times x minus 3. Plug in -1. Plug in -1. So I'm just going to do the signs. It'll be negative over negative times negative, right? Everybody okay with that if I plug in -1 there? Right? -1 minus 2 is -3, it's negative. -1 right here is negative. -1 minus 3 is -4, it's negative. Negative over negative times negative. What is that? Negative over positive, negative. So that means it's down here, isn't it? All right, that's a fair bit more work for the fractions, isn't it? That's about the easiest thing I know to do. So, all right, so there we go. Everybody seeing those steps on that? So, all right, let's go forward then. And that's all of our time. All right, can y'all do it? So go ahead and go through the steps. So step 1, set it equal to 0. Set it equal to 0 and solve that thing. So what are the answers that make it equal to 0? 4 and -2. Good enough? Just opposite, right? We good? 4 and -2. All right. Step 2, number line. Put those values on the number line. +4, -2. Step 3, check. Well, we could do the There's a couple ways. There's whatever you prefer. You could do the in behavior if you want. That's not, I didn't spell it right. End behavior, and then the B or P, or just plug in to check each section. Right, whatever you prefer. Everybody see how, because basically we have to determine, is it above or below, is it above or below, is it above or below, right? Each section we got to find out above or below. There's two ways to do that. You could just do the end behavior thing, and then kind of work your way backwards with the pass-through or bounce. That's probably the quickest way when it's not a fraction, right? The only time you can't do that is at vertical asymptotes, right? We don't have any of those here because we don't have a fraction. Is that making sense? So go ahead and try that real quick. What's the end behavior? It's y. And remember what end behavior means? That means if you just FOILed that out, what would be the most powerful term? What would be the front term? You just take the most powerful term here. That'd be x squared, and this would be plain x. So it would be x cubed, which is positive. Positive x cubed. That means it's going up. Y equals positive x cubed. That means it's got to go up off to the right. It's got to, because this is the most powerful term. It's going to dominate the scene. Eventually, I mean, if you plug in big enough x values, it's going to dominate eventually because it's the most powerful term, right? The other terms are smaller. Even if they're negative, they're less important, less powerful. So it will dominate. It must be going up, up, up to the right, like that. Okay, and then figure out if 4 is a bouncer or a pass-through, and then if -2 is a bouncer or a pass-through. Let me give you just a second, see if you can get that. All right, what about 4? Look at the power on 4. It's a bouncer because it's even power on the 4, right? That's a bouncer. So boing, it's going back up. And what about the 2? First power, it's a pass-through on the 2. Pass-through because it's an odd power. We good there? I think it's a little easier than plugging in values. All right, now let's answer the question. What is the question after all that? It's like almost graphing, huh? They want to know where's the thing less than 0, don't they? They want to know where are the y values lower than 0. That's the question. So where is the thing less than 0? Yeah, there, from -infinity to -2. And that's it, huh? All the rest is above, isn't it? So where is it less? Now, do we put any brackets on that answer? No, they're just saying less than, not less than or equal to. So it's just parentheses, right? It's close to -2, but we don't include -2 because at -2 it's equal to 0, and they don't want equal to 0. They only want less than 0. We got it. We flew the plane blind by the instruments. Is that good? That's the purpose of this. This will be very useful in calculus, being able to take a function with no picture and figure out quickly where it's above, where it's below, and you'll also be finding maxes and mins in calculus by hand without a calculator. All right, questions on that one? So what we're doing here is we're learning to grow in our ability to figure out what a function does without having a picture. All right, there's a lot to this section. Number 9. All right, what's the... so let's go through the steps. Again, we're flying the plane blind. Step number 1, I really should have said you've got to get a 0 and factor. That's really step 1. Get a 0 and factor. So we take that 4x cubed greater than minus 36x squared, like that. Right away, just jump this over. And I'm going to just make it equal. Remember how we just make it equal to 0? Right? Like that. You know what? Let me not do that, actually, having just said that. There's just a lot of ways to do this. Let me keep it greater than 0. Let me just keep it as it is. All right. So there it is, right? I just got a 0. I need to factor that now. How do we factor this? How's your factoring? I'm glad to help you with this. I know it's rusty. Yeah, GCF. Do you remember that? come by. I'd be glad to help you. I can probably, if you're having trouble. It's really important that you're comfortable with all the different factoring. This one you're probably easy right for you, right? 4x squared, right? You take the number that goes into 4 and 36 is 4, and you take the lower of the two powers, huh? And then 4x squared times what? Well, x, and 4x squared times 9. We'll go back to that one, huh? Good to there. Remember all that factoring? Okay. And now, what do? We find out what makes it equal to 0. Even though we're really solving greater than 0, we'll get to that in the end. For now, we have to start by finding what makes it equal to 0. So what makes it equal to 0? X equals 0 and x equals -9. Exactly. Put those on your number line. So 0, whoops, that should be, I'll make that the -9. -9 and 0. And we have to somehow figure out the regions in between. The three regions, huh? Whether they're above or below. Can we do the same thing we did last time with the end behavior? So I'm looking at this. You might wonder, well, what end behavior? Well, here we have the function right here, all multiplied out, huh? Before we factored it, so that's the end behavior. That is the most powerful term. So everybody see what end behavior is? It's the most powerful term when it's all multiplied out, all FOILed out, right? So the most powerful term, because that's the dominant one. That's the one, if you plug in really, really, really large numbers like 1,000 or 1,000,000, he's going to dictate whether the thing's positive or negative because the other stuff is smaller and less important. So eventually he'll take over. So it's positive. So end behavior is positive, which means it's positive. In the right, off to the right, in the end. Right? Positive. Okay, now is 0 a bouncer or a pass-through? Look, now that requires the factored version. You guys okay with how I keep moving back and forth between the multiplied version and the factored version? So for the bounce information, you're looking at the power on it, which is the factored version. I'm looking right here, and that's an even. So he's a bouncer because it's even. So boing, he's going to bounce, huh? Because the power in the factored version is even. How about the x minus 9, or x plus 9 right there? First power, so that's going to pass through because it's odd. So there's the basic graph. It's going to go like that. And what do they want me to add? Now, it might be confusing. Well, it's right there. It's greater than 0, huh? The original we first got as 0. So you're really looking at this version here. You're saying, where's the thing greater than 0? So where is it greater than 0? Here and here. Do I include this 0 spot? See, that's important. There it's right on the money 0. It's not greater than 0. So in other words, my answer is -9 to 0 united with 0 to infinity. No brackets on anything because there's no solid bar here, right? Where if that had an equals, if that was greater than or equal to 0, then I would just say, hey, it's all the way from -9 to infinity, wouldn't I? Because I would want to keep that, right? Making sense? But we don't want to keep it because we don't want the equal 0. So there is our answer. All right, we can squeeze one more, even tomorrow. All right, try that one. So go ahead and factor that one. Can you do that? Maybe I'll run through roll while you factor, if I can get through that. Rania is here, and Victoria Alonso, Victoria New, and Katharina is here, and Emmanuel is here, and Ursula is here, and Carlo is here, and William is here, and Eros is here, and Tanya is here, and Kelton is here, and Shane is here, and Tim is here, and Edgar is here, and Jessica Farmer
Seth. Shadowy is here, and Phoebe Lopez is here, and Long Lure is here, and Celeste Dominguez is here. Mirovich is here, and Nina is here, and Isaiah Mendez is here, and Malik No, and Robert is here, and William Nelson is here, and Juan O'Leah. And Benita is not here. And Tanya Ramirez is here. And Michael Rubalcaba is here. And Mohammed Salah is here. And Christian is here. And Mariana Santos is here. And Jorge Saravia is here. And Guadalupe Valinda. And Ana Eri is here. And Orlando Soto. No. And Vincent Tao is not here. And Taras, no. All right, and Destiny Valenzuela, no. And Chang Lang is here. And Diego Vargas is here. And Alyssa is here. And Richard Zong, no. And Samuel Zong is here. And Chu Yang is here. And Fidel Zuniga is here.
All right, yeah, so let me just factor that and I'll let you go. So to factor that, you'd first take out an X, right? So first take out the X, and then you got to do the FOIL thing on what's left. I know that's hard for some, I'd be glad, come by office hours. I can work with you half an hour, or go see Roberto. So you're basically looking for what multiplies. Remember, it's add in the middle, multiply at the end, right? What times what is 80? What multiplies to be 80? Well, a lot of things. Use your calculator. And then tell me what it is. 420. 810. Oh, 810. Yeah, 810. 810. So minus 10 plus 8, because the sign in the middle always goes on the bigger. Anyway, so that means 0, negative 8, positive 10. Put those on the number line. 0, minus 8, positive 10. End behavior, x cubed, positive. Positive, that's the end. And all these are passers through, aren't they? They're all first power. Pass through, pass through, pass through. They want greater than 0. That's here and here. Give them those sections. So negative 8 to 0 and 10 to infinity. No brackets because they had no bar. All right, this is not due. We gotta do a lot more. So it'll be due on later. What is that? Monday? No, Thursday. Thursday. We'll be doing Thursday. Have a good day, guys. If you didn't get your exam